Docker holds an 87.67% market share in containerization. That means nearly 9 out of 10 containers running anywhere on Earth right now are Docker containers. The company essentially invented a category and then dominated it so completely that Docker and container became synonyms. So let's break down every major Docker concept and figure out what each one actually is. Docker image. This is the blueprint. An image is a read-only template containing everything needed to run an application: the code, the runtime, the libraries, the system tools, and the configuration files. Think of it like a recipe. The recipe itself doesn't produce food. You need to actually cook it. An image doesn't run anything. You need to create a container from it. Images are built in layers, where each layer represents an instruction in the Docker file. Install Python? That's a layer. Copy your app code? Another layer. Install dependencies? Another layer. Docker caches these layers, so if you change your app code but your dependencies haven't changed, Docker reuses the cached dependency layer and only rebuilds what changed. This layer caching is the reason Docker builds are fast after the first time. Docker container. Now you're cooking. A container is a running instance of an image. It's an isolated process on your machine with its own file system, network, and process space. Multiple containers can run from the same image simultaneously, each completely independent. Delete a container, the image still exists. Create 10 containers from one image. They all start identical but can diverge as they run. Containers are ephemeral by design. They're meant to be created, used, and destroyed. You don't patch a running container. You build a new image and replace the container entirely. That mindset shift is what makes Docker fundamentally different from traditional servers. Docker file. The instruction manual for building an image. It's a plain text file with commands like from, run, copy, and cmd that tell Docker exactly how to assemble your image step by step. From Python 3.12 says, start with the official Python 3.12 image. Copy./app says, copy my code into the container. Run pip install -r requirements.txt installs dependencies. cmd python app.py tells the container what to do when it starts. A Docker file typically takes 5 to 20 lines. Quick question, what's the longest Docker file you've ever written? Drop the line count in the comments. Docker Compose. Running one container is easy. Running 10 containers that need to talk to each other, a web app, a database, a cache, a message queue, is a nightmare without orchestration. Docker Compose lets you define all your services in a single YAML file and start everything with one command: Docker Compose up. Your web app runs on port 8080. Your PostgreSQL database runs on port 5432. Your Redis cache runs on port 6379. And they all find each other automatically through Docker's internal networking. Compose is the reason developers can clone a repository and have a complete development environment running in under a minute. Docker Hub, the app store for container images. Docker Hub hosts millions of pre-built images that anyone can pull and use. Need a MySQL database? Docker pull MySQL. Need an Nginx web server? Docker pull Nginx. Need a specific version of Node.js? Docker pull Node:20. Official images are maintained by the software creators themselves and scanned for vulnerabilities. The free tier gives you one private repository. Most people, including myself, think Docker Hub is one of the most underappreciated pieces of internet infrastructure. It's basically the foundation that modern deployment is built on. Docker volume. Containers are ephemeral. Everything inside a container's file system disappears when the container stops. That's a problem if you're running a database. You don't want your data evaporating every time you restart. Volumes solve this by mounting a persistent storage location from the host machine into the container. The data lives on the host, not inside the container. Delete the container, the data survives. Replace the container with a new version, the data is still there. Docker containers handle state in a stateless world. Docker network. By default, containers are isolated. They can't talk to each other or to the outside world unless you explicitly configure networking. Docker provides several network types. The bridge network is the default. Containers on the same bridge can find each other by name. The host network removes isolation entirely and lets the containers share the host's network stack directly. The overlay network spans multiple machines, which is essential for distributed deployments. Understanding Docker networking is the difference between a container that works on your laptop and a container that works in production. Container runtime. Docker is actually two things: a developer tool for building and managing containers, and a runtime that actually executes them. The runtime is called containerd, and it's the piece that Kubernetes actually cares about. When Kubernetes dropped Docker as a direct runtime in version 1.24, people panicked. But nothing actually broke, because Kubernetes was already talking to containerd underneath Docker the whole time. Docker was just the middleman. CRI-O is the alternative runtime, built specifically for Kubernetes with no Docker dependency at all. For most developers, this distinction doesn't matter. For infrastructure engineers, it's the kind of detail that determines whether your cluster runs smoothly or catches fire at 3 a.m. Docker Swarm. Docker's built-in orchestration tool for running containers across multiple machines. Swarm turns a pool of Docker hosts into a single virtual host. It handles load balancing, service discovery, rolling updates, and self-healing. The problem is that Kubernetes exists. Kubernetes won the orchestration war so decisively that Docker Swarm is essentially a legacy technology. Kubernetes holds 92% market share in container orchestration and serves 5.6 million developers globally. Swarm is simpler to set up but lacks the ecosystem, community, and feature depth of Kubernetes. If you're learning container orchestration in 2026, learn Kubernetes. Swarm is fine for small, simple deployments, but the industry has spoken. So Docker in 2026 is this. Images are blueprints, containers are running instances, Docker files are recipes, Compose orchestrates locally, Hub stores everything, volumes persist data, and networks connect it all. The container revolution didn't just change how we deploy software, it changed how we think about software. Applications became portable, environments became reproducible, and the phrase, "it works on my machine," became a problem Docker was specifically invented to kill. Every API type explained is on the screen. Go watch it next.